Alright, so in this problem, I have 7 to the power of x plus 8 is equal to 8 to the power of x plus 7. So to start, if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So in this case, 7 to the power of x plus 8, that's going to equal 7 to the power of x times 7 to the power of 8, and 8 to the power of x plus 7 is equal to 8 to the power of x times 8 to the power of 7. Now, I'm going to divide both sides by 7 to the power of 8 times 8 to the power of x. So then on my left-hand side, both 7 to the power of 8's cancel out, and on my right-hand side, both 8 to the power of x's cancel out. So now I'm going to be left with 7 to the power of 8 over 8 to the power of x is equal to 8 to the power of 7 over 7 to the power of 8. Now, if I have something in the form a to the power of m over b to the power of m, this is equal to a over b to the power of m. So 7 to the power of x over 8 to the power of x, that's going to equal 7 over 8 to the power of x. And now this is equal to 8 to the power of 7 over 7 to the power of 8. Now I'm going to take the log on both sides, so I get log 7 over 8 to the power of x is equal to log 8 to the power of 7 over 7 to the power of 8. Now if I have something in the form log a to the power of b, I can move this exponent b to the front, so it's going to equal b times log a. So in this case, I get x times log 7 over 8 is equal to log 8 to the power of 7 over 7 to the power of 8. Now, log 7 over 8, that's the same thing as log of 7 minus log 8. And now, I'm going to go ahead and divide both sides by log 7 minus log 8. So then these two cancel out, and I get x is equal to log of 8 to the power of 7 over 7 to the power of 8 over log 7 minus log 8. Alright, so in this problem, I have 2 to the power of 3x minus 1 is equal to 8 to the power of 2x minus 1. So, I want to find the value of x in this problem. So for my solution, I'm going to first start by rewriting my equation. So my equation was 2 to the power of 3x minus 1 is equal to 8 to the power of 2x minus 1. And what I'm going to first do is start by rewriting 8 here as 2 to the power of 3, because 8 is equal to 2 to the power of 3. So now I have 2 to the power of 3x minus 1 is equal to 2 to the power of 3 to the power of 2x minus 1. And the reason I did this is because now these two have the same bases. Both of these bases are 2, so it's going to be much easier to solve this equation. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So in this case, we have 2 to the power of 3 to the power of 2x minus 1, and we can think of m as 3 and n as 2x minus 1. So this is going to be equal a to the power of m times n, so 3 times 2x minus 1. So now I have 2 to the power of 3x minus 1 is equal to 2 to the power of 3 times 2x minus 1. And 3 times 2x minus 1, we simply have to distribute the 3. So we get 2 to the power of 3x minus 1 is equal to 2 to the power of 3 times 2x is 6x, and 3 times negative 1 is negative 3. Now, if I have something in the form a to the power of m is equal to a to the power of n, this means that m is equal to n. Meaning, because both of these bases are the same and they're both equal to each other, this means that the exponents are equal to each other as well. So meaning 3x minus 1 is equal to 6x minus 3. So we have a simple equation here, and to solve this, I'm going to first start by subtracting 3x on both sides. So I get negative 1 is equal to 3x minus 3. If I add 3, I get 2 is equal to 3x, meaning x is equal to 2 over 3. Alright, so in this problem, I have 3 to the power of x plus 3 to the power of x plus 3 to the power of x is equal to 333. So, the first thing I'm going to do is factor out 3 to the power of x from my left-hand side. So now I have 3 to the power of x times 1 plus 1 plus 1 is equal to 333. Now, I'm going to solve what's in my parentheses. So I have 1 plus 1 plus 1, that's equal to 3. So now I get 3 to the power of x times 3 is equal to 333. Now, we want to isolate 3 to the power of x here. And the way to do that is to get rid of this times 3. So I'm going to get rid of this times 3 by moving it to the right-hand side, and I'm going to do that by dividing both sides by 3. So now I get 3 to the power of x 3 to the power of x is equal to 111. Now, if I take the log on both sides, I get log 3 to the power of x is equal to log 111. Now, if I have something in the form log a to the power of b, I can move this exponent b to the front, so it's going to equal b times log a. So in this case, I have log 3 to the power of x, and I can move x to the front. So I get x times log 3 is equal to log 111. Now if I divide both sides by log 3, these two cancel out, and I get x is equal to log 111 over log 3. Now, I can write my solution in two ways. The first of which is to actually divide log 111 by log 3. So log 111 divided by log 3, this is equal to 4.29. So this is one way I can write my solution. Now another way I can do this is if I have something in the form log a over log b, this is going to equal log base b of a. So this is another way of writing my solution.